let's go right from the beginning. What's the point of this thing? Right? All that stuff, like what's the goal, blah, blah, blah.
The point is to basically give people the ability to sort of get staking power with leverage, right? Because we discussed previously that staking power is king when it comes to what's important for Stakehouse provide or block space provided Stakehouse operators. And so like in normal Stakehouse, you would be able to, let's say, create a few nodes, then mint derivatives, sell them, create more nodes, etc. But you have to wait the deposit period each time. And then that's just a very cumbersome process. You can also just get slippage, like get exchange rate fluctuations, so all that kind of stuff that makes this far less attractive. But what if you had basically a pool where you could just borrow funds and immediately get all of those like knots that you would be able to get from this kind of wrapping operation, and it's much more seamless. There's less friction. So basically, you could just do this in one click. So that's the base idea behind compound staking. And to do that, we have two parts to the mechanism.
Ivan, can I interject here? So, is it possible to see these interactions like in a diagrams or anything that, so I could understand you say that you can borrow from where you borrow, like how does this happen? Like somewhere, because staking is like, you put the money into Ethereum and then Ethereum will take it away. And how do you know that who's going to it? But just maybe high level.
I don't have anything on hand. I guess I could draw right now.
Yeah, we can go on the fly. Yeah. What I'm interested in is the financial difference here. Like, if I'm using vanilla Stakehouse protocol, what difference is that from a financial perspective to using compound staking? How much ETH do I need on both, like with either option? And what am I borrowing? Am I borrowing the full 32?
Excuse me, what was the last question?
Am I borrowing like all the 32 ETH to stake? Am I getting money for free or?
Oh no, you can borrow basically as much as you want. So if you want to just set up one knot, you can bring like 8 ETH and then borrow 24. You have to bring like 8 plus a small amount to cover the interest, but basically then you borrow 24 and you can set up one knot, which you cannot do otherwise, right? Because in Stakehouse you would have to bring the entire 32 ETH, or like in normal ETH staking as well. So that this decreases the capital requirements, like for a minimal staking operation, right?
What is a knot?
A knot is just the Stakehouse term for a single ETH staking.
Oh, that's like CDP for a validator.
I guess in some sense, yeah.
Okay.
Yeah. So, sorry, I also have a question. So basically, how much can I borrow, and what does it depend on, essentially?
So this is actually fairly straightforward. So I can just show you the part of the code that's responsible. So here we have fund extra nodes, right? So basically what this function does is that it determines whether you have enough collateral to actually borrow the amount that you're requesting to open the particular number of nodes that you want. And the base idea is this: we know that a single deposit period takes approximately, let's say, 24 hours, or at least that's like the upper boundary. So like 72 hours is like very, very bad case scenario of how much it would last. And so we determine whether the user has enough of their own ETH to basically cover the entire debts after they mint their derivatives, and then also some extra on top to pay interest for 3 days, basically. So it's not necessarily that they will have to pay interest for 3 days. They will just have to pay whatever interest they accrue over the period that they, wait for the deposit to get processed and mint their derivatives. But they have to cover like at least 3 days. And then basically we just make this sort of computation, right? So you have the number of knots that you want to create, so that determines how much collateral you will have after the operation is complete. And so you can just compute that as a number of knots multiplied by 24 ETH, which is the number of the ETH you mint. And then you just check that it's more than the amount of ETH that you borrow plus the interest that you compute based on the current rates in the borrowing pool.
So is the user paying interest in ETH, right? So you like, if I want to, like, basically I want to set up 2 validators to get the slots, and so that'll be 16 ETH I need to supply, 2 times 8, right? And I'm going to borrow the 48 ETH to meet the requirements of the Ethereum deposit contract, right? So the 64 ETH is required to go to the contract before a validator will get activated, right? So am I supplying additional amounts in ETH to fund the interest rates for my borrowing?
So everything that you bring is in ETH, right, on this side. So this is like the contract for the users, right, for the staking providers that want to borrow. So you provide just your collateral in ETH, but when you actually deposit that into ETH2 and then mint your derivatives in Stakehouse, you will get the ETH, right? And so what happens actually in the pool is that it's not like your usual system where you put one asset and just get more of that asset over time. It's kind of like a pool where you swap ETH to the ETH with a certain like premium on top. So let's say like if you would, so basically if you bring like your ETH as collateral, you would borrow also ETH from the pool, but then when you repay the your debt, it will be repaid in the ETH. And we assume like the ETH sort of has parity with ETH, but then you also have this interest on top, and that creates yield for users, or a kind of sort of a way to buy the ETH at a discount over time.
So can I ask a question here? Because the way that I'm understanding the whole thing works, this is a borrowing strategy that will allow you to get as much as validators from Ethereum and pool the capital from a large number of users. And in order to incentivize this pooling, just like it's a borrowing pool where you say that you lend me money for some time, maybe a day or 2 or a week maximum, and then it will pay you X amount of interest end of that time, right? Where your inbound is ETH, and you will your outbound is ETH to the pool, but the pool will give you back staked ETH that has already staked in Ethereum. You have now a ETH with 5 or 6% or 4%, whatever it comes, 100% to you, and that's to you. It's called the DETH. But on top of that, I also give you some interest providing this capital. Is that correct? Yes. It's like a kind of borrowing strategy.
Yeah, yes, the interest is also in the ETH as well. Basically, you just you take ETH, but you bring the ETH back.
Right. So, but you at the moment, like any borrower, you need to pay up the upfront. Like you need to have some money extra. So let's say 32 ETH is required, 8 ETH is in your hand, and you're borrowing 24 ETH. You pay back the 24 DETH plus some interest?
Essentially, yes. So you will have to have like slightly more than 8 ETH collateral. It's not going to be like a large sum. It's maybe like
right. So let me Yeah, let me take this to a scenario where in DeFi you have borrowing pool strategies, right? Borrowing strategies.
Sure.
And normally, like you're a protocol now. You source the capital and you put it, and you have the 8 ETH essentially that you see in the MEV fees, whatever it is that you're getting. So you're basically going after that cash flow. That is the execution layer payouts. But your the 24D ETH get all the consensus layer payouts. That's a newly minted ETH from the validation process. Now, you want to get this MEV like it's a very ETH liquid cash. Great. Now, would it be possible that you can also incentivize with your tokens, like if it is a protocol, you basically get this kind of governance tokens or any other tokens can be attached to it, and say that the borrowers you can mitigate this initial cold start problems or the interest from any other tokens, or is it really mandatory to have this interest to be in the DETH or ETH denomination as a must?
It's preferable too, because well, the thing with the ETH and ETH is that they are like very highly correlated, if not like entirely pegged to each other. So it's easy to take money in one and repay in the other. If you actually repay in different assets, then you would have to compute a lot of like, more complicated calculus, especially regarding the slippage and so on. And so this largely complicates the contracts and like economical analysis of the system overall. Right. So I would prefer to keep it like just the ETH and ETH for simplicity.
Nice. But you can add additional tokens as well, right? As a liquidity mining, whatever you want. No
you could essentially like have a sort of like yield accrual vaults like Vion on top, right? So you have this kind of borrowing pool where you get the ETH back, but nothing stops you from having a vault on top of that, which would accept ETH and then just sell all of the ETH that it gets back into ETH. So you would have basically like a normal vault for ETH that gets ETH denominated interest.
Thanks. All right, cool.
Okay, so we were. Yeah, sure.
Yeah, right. This money comes from somewhere. Well, so there's obviously, like Uniswap, there's two sides of the borrowing, and then there's the lend. Sorry, not Uniswap. Aave compound, right? There is sort of somewhere where LPs go to add liquidity, somewhere where people are going to borrow money, right? What you're showing us is the borrowing part. Is the
right now I'm actually showing you the lending parts, I guess. Or like, what do you mean by borrowing parts? I guess the part where people come to borrow money, if that's the case, yeah, that's it. So like we have, it's kind of like, it's not even a completely correct way to describe that, because essentially you have the pool that handles both borrowing and lending. It doesn't really like discriminate what it lends to. Well, it expects like the contract that it lends to compute the borrowed amount and so on correctly, but basically you could attach that pool to some other strategy that works similarly or maybe differently. But here we have a sort of a contract that simplifies the process for leverage staking, basically. So that's like the user of the pool, essentially. It's not really like the lending side per se.
Okay. Yeah, I think that's clear. But obviously we can't start this without money, right? Without ETH. So they're the first ones to come in, right? How are they? Are they just, is it just a simple, you put, rather than with Uniswap, people are used to like a 2 pairs, liquidity provisioning, but here we're just, it's a single token and you get a single LP token back, right? I'm just assuming based on standard DeFi patterns.
For the mechanics of this, it's basically what you do is that you deposit ETH, right? So we have a payable function here, and you're completely correct that it gives you a share token in return. So the difference here is that the share token kind of like you have other pools where the share token just its value always grows, but here the share token is actually gives you rights to the parts of a like shared ETH pot that constantly dwindling because it basically sells ETH for DETH. So what your shares allow you to do is they allow you to withdraw the share of the currently existing ETH in the pool, but that decreases over time. So for example, if you have like half the shares, but then half of the ETH gets sold for DETH, then you will be able to only withdraw back half of the ETH, but you get those like DETH as accruing as rewards. So it's like the contract itself is part borrowing pool, but also part MasterChef. So it has like one side. On the ETH side, it's more like borrowing pool, but on the DETH side, it accrues exactly like MasterChef does. So there is like a an integral of all of the rewards over time. So the calculus is the same.
So if you're saying MasterChef, you're saying kind of like it's not exactly, but you could say like, oh, your ETH is being staked and consumed, and the reward token you're getting is the ETH, right?
Essentially, yeah.
Right. What I saw something. What's this with index update? What you have some modifiers on this deposit on all your functions.
This is just to like decrease the amount of code. So basically we have two modifiers, right? One is with index update. The second is with lender update. So with index update is basically it just requests the latest borrow rate from the interest model, which is like a separate contract to make it replaceable. So this is
borrow rate. You wanna expand?
Here, right? So this requests the latest interest rate, and then it computes like the new value for the interest index, which is also kind of a like integral of all the interests, right? So it just grows over time. So basically what it does is that before any function that would realistically modify the interest rate, like deposit and withdrawal functions, which would change like the balance of liquidity and therefore change the interest rate, we want to compute like the new value for this cumulative index for interest. Because like between the operations that change the interest rate should stay the same. And so that means we can just compute this new index value by multiplying like the interest rate by the time that elapsed since the last change, and then adding that to the current index. So this is what exactly what's happening here. So basically we have the current index, which is just multiplied by 1 plus whatever the interest rate got accrued over the period since the last update. And then when we update that, we can just set the last update timestamp to block timestamp, and so we get like the most current index value, and then we can update safely the interest rate. So all of the calculations so check out. So that's for
it's dynamic, right? The amount of interest I could be accruing is dynamic. Then what is the basis for adjusting the interest rates?
Well, it is dynamic based on just, as usual, it's on the utilization ratio, right? So we have assumed liquidity, which is just the total amount of ETH that's kind of like it's just the sum of the borrowed ETH and whatever ETH is in the pool right now, and available liquidity is just the ETH in the pool right now. So based on that, you can just compute the utilization ratio, and here you go. You can compute the interest rate.
So then you can, like, for all the ETH that's utilized, you know how much money you're going to get once it gets lent out to borrowers.
Excuse me, what was that? Sorry, I didn't quite hear it.
If I deposit 100 ETH and 50 ETH is being utilized, so there's like a 50% utilization. But I guess can I for the ETH that's been borrowed from the pool, I'm guessing I will be able to predict how much interest payment I'm going to get, right?
Essentially, yes. But it's important to remember that the interest actually is yeah, well, one thing important to remember is that even though the borrower actually provides like enough funds to cover interest for 3 days, if the repayment time is larger than 3 days, then it may be that they would not be able to cover the entire debt, including the interest. So it's not catastrophic, right? Because they would still like pay at least interest for 3 days. It's just kind of like profits that are not kind of just underperforming, but that should be rare, just based on the dynamics.
Let's say you have this utilization pool. Normally, the lending and borrowing pools, like amplify the interest rates, right? When there's more utilization comes in, right? For the lending.
Yeah.
So if I'm a liquidity provider, if I see the borrowing pool needs some more ETH to honor deposits like the validator, and it's like close to 3 days. I can my opportunity cost is less compared to others, where I can just simply provide, and that will be immediately taken for the staking, and I'll get the DE because once the staking is confirmed, I don't really have to wait for 3 days, but I will get much better interest. No?
You mean because the interest gets
some kind of an arbitrage, right? You don't really have to give your ETH for 3 days. You may only end up giving only 1 day.
Yeah. I understand what you mean. Let me think about that for a moment. I guess not, because that depends on the index. So let me show you actually how the debtor position looks, so I can explain it better. Just a moment.
Yeah, my brain is thinking, just put this borrowing pool on top of LST, right? Anyone can just have their own strategy protocols.
I think that was in the interfaces or something. Or maybe not.
It's not a bad thing. It's a good thing. Market
Yeah,
cares to provide money.
I think you're right, because basically it accrues in the same way as the master chef. So if you anticipate like a large amount of interest coming into the pool soon, you can just buy more shares, and that will get accrued to your shares. Yeah, you're correct. That's true.
Interesting. Nice.
That's sort of like the a similar mechanism to what happens like in a normal borrowing pool when you're short on liquidity, right? Because well, basically the interest rates jump up, and so you have an incentive to just add more liquidity and like utilize those short-term increased interest rates. So I guess this is kind of a similar system in a way.
So having said that, what is like your thesis when you when you write in this code? Like, have you looked into some of the DeFi protocols, like how they are doing, and try to simulate some of the behavioral aspect here? Like, what is your exposure in general DeFi? Like, just trying to understand here.
At least the interest computations are heavily inspired by AVA, so they look similar there. They also have this sort of multiplicative index as well that's used here. It's just a very like sort of natural way of computing interest over time, right? Because basically you can you don't have to store like interest computations anywhere. You can just compare the current index with the index when the debtor and borrowed, and that creates interest. So you can always computed dynamically, which is really cool. And otherwise, the second part that's related to the ETH is just a normal master chef that's used practically everywhere.
So this actually brings kind of very familiar tactics in the market. So when someone actually want to try to use your plugin, this code, you think like, the calculation methods are very familiar to them. The strategies are very familiar. All you're trying to do is like how to optimize this capital efficient coordination for initial capital that is required to do the ETH staking.
Essentially, yes. Although, like, based on just the fact that you would have your revenue in a different asset. If you're a pool LP, the actual relationships might change quite a bit. Like one of the things that you've described already regarding the arbitrage, right? Because you have, if you take, let's say, an Alva pool, that shouldn't be ideally possible there, because you would want to just give users sort of like fixed, well, not fixed, but predictable yields over time. And so you, if you have a person that makes large deposits into the pool, their revenue will still be computed based on the interest index. And so because they didn't exist in this pool for quite a long time, they will not get a lot of revenue. Whilst here, it's different, right? So there's sort of this arbitrage opportunity.
Nice. So this is actually pretty cool, pretty interesting, because the reason Alice want to set up a borrowing pool, because Alice is more interested in the execution layer payouts, which recently that we have seen that it's more than the average staking yield, and it just going like skyrocketing, because you can if you're lucky to get like 2 blocks, and then your MEV bribes will be much more higher. So these are money. So she's interested to do that, and she put a borrowing pool. Now the market actors have not only incentives just to provide a vanilla interest that is offering, but they can also have this kind of dynamic opportunities where they can optimize for their opportunity cost, looking at what time it is going there and how much liquidity is there. So everyone is playing for their own benefit. And by default, Alice is giving up all the staking yield, if I understood correctly. She's like more wanted to run the node and get this execution layer payout and go run a block building business and run a relayer, whatever it is, right? This is the business, but other parts of the tokens are going out. The market is basically the staking yield. So they are getting that incentive as a DETH, but the initial lender, you're saying that one layer abstraction above, the lender also have multiple interests here. Not only it's a vanilla lending market, but it also gives some kind of an additional opportunity, like you can optimize for the time when that is getting priced.
I think one like effect of this is that this may not be entirely friendly, like for put money in and forget kind of strategies, right? Which you could do, let's say in Ava, like you may have suboptimal returns, but you would have like some kind of return. But while here, it probably warrants a much more active participation and sort of management of your position. This might not necessarily be bad, especially since you can just, as I said, you can build a vault on top and just manage that, and then people who are more passive can bring money into the vault and not bother.
Yeah, this is an exposure vehicle here. What you have.
Another issue is that you would probably have your borrowing rates more volatile than in your typical like borrowing pool in the rest of the DeFi, because the demand for borrowed funds depends on when people want to create new knots, which is sporadic, basically. Yeah. So you would have situations where, for example, a large whale comes in, then just the interest rates skyrocket because they've borrowed so much, but for a short term, because it's basically for short-term loans. So you would have to, as an LP, you would have to manage that quite actively, I think.
This is similar to you know, from a perspective of actively managing a position. This is similar in the sense to Uniswap v3, whereby you're defining a position between some tick range. You're doing like some range based order, and you have every incentive to manage that position and update it and bring it into the correct ranges and you know, etc. But there are protocols though that are specializing in that for people who want the benefits of Uniswap but want the to do it more passively. So there's protocols that come along, they go on top of Uniswap v3 and they will actively manage the position. You give them the liquidity, they give you an LP back, and then they will actively manage it, like you said, based on, you know, and it could be in this case with compound staking, it could be, you know, if the interest rate spikes, that, you know, you can manage and deploy the capital as actively or inactively as you want, depending on whether you want to use an additional protocol on top, right? But it's very composable.
Essentially, yes. I mean, it's probably not as complex to use as Uniswap v3 when we talk about LPs, because Uniswap v3 is like notoriously complex and not profitable for most of its LPs. And here, I guess the dimensionality of what you have to consider is probably lower, right? So it's easier to manage, but the basic relationship is probably the same, yes.
You can also do interest swaps, like, you know, looking at where the liquidity is there, what's the borrowing rate, and etc. Like, for example, protocols like Walls and other kind of things, they take USDC and lend it for, and then, you know, lock it up for certain days, and that's the interest that you're trading. So you can have this kind of borrowing rate and lending, you know, borrowing rate and the interest rate spikes. You can trade for that too.
I suppose so, yeah, but it's kind of like more complicated product built on top, right? So
no,
probably
what I'm saying is Walls is already doing it. They can basically use this as a mechanism as a sourcing, and then they can track they can basically add a market like ETH staking market, and like not only you're not talking about vanilla ETH staking yields, rather than, you know, the liquidity going into the staking and the borrowing pool spikes. So it's a nice arbitrage in between, and then you can trade it. But people they can actively manage that liquidity and say, like, you know, I put some amount of money and the interest spikes, we'll put more and that strategy, and then we get that interest and we'll trade it to our liquidity providers back. That's the business model.
I mean, there's quite a lot of products that you can build just on top of a normal borrowing pool, and here you also have arbitrage opportunities. So there is probably more opportunity for just active management, which probably makes it more interesting, but also more complicated.
I see this as like an adapter for utilizing staked ETH in DeFi. You know, it's highly so this is obviously on top of the Stakehouse protocol, and it's highly programmable here. That, you know, the fact that you could do this base compound staking, and you can build further derivative products on top of that, right? And you can add extra instruments and stuff like that. But what I was interested in talking a bit more about as well is this. So in, you know, there is a different dynamic here when interacting with when you introduce the assets that are being minted from the Stakehouse protocol. So you know, the Stakehouse protocol is not minting derivatives the second that ETH is deposited, right? It is, you know, ETH has to be sent to the deposit contract, and you have to wait until it gets activated on the beacon chain and before you can mint derivatives on the Stakehouse protocol. This is exactly like solo staking, but you're actually getting a liquid token on top of that, right?
So yeah, you restake the validator position back to the execution layer once it is confirmed by the.
If you could actually do that like atomically, right? If you could just stake and get the derivatives immediately, or just some kind of a like receipts immediately, then all of this wouldn't be necessary, right? Because you could just get the receipt on your execution layer, sell that, deposit more, get the receipt, and so on. So you could just do that in one transaction. So that's much easier. But it's delayed for security reasons. So you need something like this to do this seamlessly.
Yeah, so a smart contract cannot confirm until the blockchain is confirmed, right? There's a consensus logic. There's a consensus specification. There's a specification for staking. So there's a fork rule distance between when you send staked amount to the consensus layer, and it will take about 2048 blocks distance and to get confirmed. Once you have confirmed, that's an eligibility epoch, and then your deposit you send to the consensus layer via Ethereum deposit contract has been accepted for validation rights. Then only you have a right to a stake deed. Up until that time, it's that's why you cannot do atomically. If you do atomically, then you have stranded balances, which is not accounted for an active validator. So
essentially, it comes down to like consensus stability and security, basically.
Yeah. So you restake once the validator confirmed in consensus layer. You can still, it may take maybe 2 hours or 3 hours or a day, depends on the queue, for the consensus layer to actually start giving you the validation job. But your deposit has been accepted within 2048 blocks, like it's about 12 hours or so. But from that point onwards, you have a right of a validator balance in the consensus layer on a BLS key. You can restake that. So you have 32 ETH. You can restake that state from consensus layer back to execution layer, and you can prove in execution layer, I have a balance which is proof of consensus attested. Boom, then you can mint a token. So that's how the redeemability of that every DE is tracked back to a balance in a specific validator on a consensus layer.
Which means there's no dilution, right? Because you're only minting once the asset is activated, right? Eligible for activation. Yeah.
Same like as a VETH, there is no peg, there is no notion of oracle. You don't really need to worry about an oracle. It's all on-chain information, verified with a proof of consensus. It's already been in chain. No one can change it once it's there. So 100% redeemable. The smart contracts is only accounting for the asset in its possession on chain.
Yeah, so that introduces, so for you, Ivan, as the builder of this protocol, this introduces a new dynamic for you, right? Because there is an async process taking place here. ETH is sent to the deposit contract, but you cannot give the users the derivatives until there is, the consensus layer has issued an eligibility epoch for that validator, right? But despite that dynamic, you can still build all kind of protocols on top of the Stakehouse, right? Talk through that, those kind of challenges, and the need for a smart wallet, and that sort of stuff.
Well, that's actually interesting, right? Because well, I mean, the delay in depositing and then being able to be acknowledged as a validator and getting your derivatives minted, that necessitates like the borrowing. But if you go like to the strategy itself, right, you do have this relationship with where you basically have to provide collateral for that, and that collateral comes in the form of derivatives that we know will be minted at some point in the future shortly, but you have to make sure that the debt is actually repaid, right? Because if they are minted just to the user, they can just take them and go without repaying the debt. So basically breaking the pool. So in the Stakehouse protocol, you have knots that represent like the validated positions in ETH2, and knots are by design just non-transferable and just linked to a particular ETH account, which makes my job slightly harder because I cannot just without additional tricks, I cannot ensure that this minted derivative actually goes back to the pool to repay the debt. And so I need to create basically an if account that is transferable itself. So if the knots and the place where derivatives are minted aren't transferable, then the next logical step is to make the account transferable. And so this is where smart wallets come in. And what a smart wallet is basically just a normal, smart wallet for the lack of a better word, right? So what I mean by this is that this is by no means a new concept, right? It's fairly straightforward. You have basically a smart contract wallet where you are able to execute any sorts of transactions from it. And what it does is that it stores sort of all of your funds and assets, and then it acts in the same way that your externally owned account would act, but it's a smart wallet. So, and the fact that it's transferable makes any sort of non-transferable assets, even like knots or like some kind of soulbound token, essentially transferable because you can transfer the account itself.
Is it knots or is it slot token that's not transferable, or a portion of this? Which part is?
I mean, before we mint it, basically the knot determines where the derivatives are minted, right? So you can move the derivatives after they're minted, but we have to ensure that they are minted to the place where we can direct them and ensure that the debt is repaid, right? So if the knot still belongs to the user's own account, we have no way of ensuring that they will actually repay the debt, right? Because they can just take the derivatives and just go somewhere with them. But if we have this kind of transferable wallet, what we can do is we can attach the knots to this wallet and then transfer the ownership of the wallet itself. And this would allow our strategy to actually take temporarily possession of the knot before the derivatives are minted, which means it can just take the derivatives as they are minted and direct them into the pool to repay the debt. So this is why all of this is necessary. And this also, as a consequence, sort of a side effect, makes knots actually transferable and tradable. So if you have a knot attached to a particular smart wallet, you can just create a marketplace for individual or like groups of knots on a single wallet and resell them, which is also like sort of probably a nice thing to have.
That sounds like another protocol that could be built. You can basically you could stake loads of validators and then just auction off the wallet, right, as a way of jumping into like a ship that's about to activate, right? You could just say, this is about to activate if you want it, so basically close to the activation, the wallet will have a higher price, or there's all kind of things you can build on top of it. But this sounds like
it also depends on the Stakehouse, right? Because like if you have a Stakehouse that everybody wants to get in because like it has some like super good contracts with some L2 or something, right? Then one avenue is like getting in directly, but it may not be possible because the current participants of the Stakehouse don't want more dilution to their slots, right? And so the alternative to that is just the current owners of the Stakehouse that want to leave it for some reason can just take their smart wallets with the knots attached and just sell them. And this means that there is no dilution, but new participants can come into the Stakehouse and operate those knots.
Okay. Yep. So maybe we can try. Maybe I can try something here. Can I try and switch the gears? Can I try and build a diagram of how piece together the puzzles in my head and see if my mental model after your descriptions marries up with what's going on in compound staking. Can I try that?
Of course, yeah. I mean, I don't really
Also-
like to draw myself, so I
That's-
appreciate that.
That's all good. That's all good. But just before we do that, this is public, right? This compound staking. It's can I access this or is it on a public repo? It's
Yeah, that's just in like this one particular is private, but there is a public copy of it, right? From the official Blockswap organization. So like, yeah, it's all accessible, open source.
Can we find you somewhere? And then is it
What do you mean?
in your GitHub?
Well, yeah, that's the GitHub that I'm showing you right now. Like, so this is just like the private repository, but there is a public version of it with Sartori included as well, I think.
VAN0K. Right. That's here, but there's and then there's like the Stakehouse dev. Let me try and share my screen. Let me see something here. Can you see? Yeah, okay. Yeah, so there so in the Stakehouse dev, okay, yeah, we have this public copy of the compound staking, and we have oh, okay, that's where your GitHub is linked. So that's cool. So people can find that publicly. So that's good. So let me try and piece together this in my head, right? So we have a contract. Okay, if I go into Stakehouse Dev, compound staking, we have a contract, compound staking strategy. So compound staking strategy. So this seems to be some central coordinating contract, right? For you know, doing the lending, repaying the loans, and stuff like that.
Essentially. So basically, what it does is that it walks you like through the entire strategy, right? So starting from like some operational stuff that you have to do with the Stakehouse protocol, and then just depositing on onto the consensus chain and minting derivative and so on.
So it's complete lifecycle management.
Yes, essentially.
Okay, lifecycle management. I like this. So we have this compound staking, but the compound staking strategy doesn't work without money, right? So we have borrowing pool. Right?
Yes.
Right, money goes here. So basically, we can have many LPs. So we do this, right? So each one of these can be LP1, LP2, LP3. Right. So we the LPs supply liquidity to the borrowing pool. Right. Nice. Okay. And they collect, right? They collect DETH in repayments, right?
Yes.
And interest. So repayments of the principal and repayments of the interest itself.
Yes, correct.
Yeah. So
go on, Justin.
Sorry to interrupt, but I think it's also important to clarify that it's not as if they kind of swap, liquidity for the ETH. Like the ETH comes from minting the derivatives. They actually collect the ETH once the validators are formed on the consensus layer, right? Or am I mixing something up?
Yes, essentially.
Mm-hmm.
So this is sort of, it can also be viewed as a sort of like like maybe buying the future of sorts, right? Because you basically say, okay, I'm going to give you ETH right now,
You're
and
selling
then
meat and waiting for the
in 3
sausage.
days stops, I will get the ETH plus interest. So
Okay. Matt's selling meat and getting a sausage later, right? Okay. Right. So if you're a user, right, your go-to is interacting with compound staking, right?
okay.
This is just a user here, right? We'll just get rid of this. So this is what funding, this is, what did you call it? Staking with leverage, right?
Yes.
Leverage from the borrowing pool. Okay. So this here under the hood will interact with, the Stakehouse protocol. Okay. Stakehouse protocol, there will be some level of interaction here. So this facilitates deposit to the Ethereum deposit contract, only for the purpose of registering the deposit. So it's tracking the BLS public keys. Otherwise, it cannot mint any debt positions to the to anybody, right? So you have Ethereum, right? So this will send ETH to the deposit contract. Okay. Here we are. We're depositing.
Sure.
Yeah, go on.
So the relationship between the strategy and the Stakehouse protocol is as was said, it's like full lifecycle management. So it also helps to register the initials, I think, right? I think the next step is deposit after that.
Right. Register initials, deposit. Oh. So register initials is basically registering the credentials of the validator in the Stakehouse protocol, right? So that's like, we're about to stake ETH with this BLS public key. Make sure you track it.
Yes, and then what's also important is that it links those BLS credentials to an ETH account, which is not actually the user that's taking the leverage. It's their smart wallet, which is important, as we discussed previously.
Right. So that means there's a guy in between compound staking and the user called the smart wallet, like you said, right?
Yes.
So you can have one too many smart wallets, right? So the smart wallet, so user, wait a second. User is interacting with compound staking. Compound staking will create smart wallets that are given to the user upon repaying the debt.
Yes, essentially.
All right. So let me just try and encapsulate, right? So in a flow, right? So
if you want to get technical, there's also a factory for smart wallets, right? And it's required because you want to ensure that the smart wallets are actually legitimate, because you can just bring another contracts under the same interface and steal money. So
exactly, yeah, exactly. Now let's get technical, right? So smart wallet factory. So let's just bring this. Sorry. Let's just move this down.
Oh, that's how the smart wallets are legit. Just looking at the factory address. It will only take from a factory.
Yes, the factory creates them. So you can do that separately, or you can have the strategy do that for you automatically.
Nice.
And just
Nice. Like every pool in Uniswap has been created by Uniswap Factory.
Yeah, I guess.
Otherwise, you have no, you don't have a source of legitimacy. Yeah, that makes sense. So, basically, upon repayment, user will get a smart with right, because that's the goal here. Is you want to run. So what a user is trying to do is they're trying to so compound staking strategy is helping users to borrow 24 ETH per knot, per staked knot, right? So you're trying to borrow.
I think one thing that maybe needs to be corrected here is that the user does not directly per se borrow funds, right? So strategy does on their behalf, and then it puts that like into the Stakehouse protocol to deposit in Ethereum. So basically, like the pending validated position in a sense is collateral itself. So like not ETH.
Right. Okay. You're gonna have to go through that again.
Initially, right? They basically supply a smart wallet, and they wait until the debt gets repaid from the same smart wallet. So the smart wallet actually holds like the physical assets.
They're supplying 8 ETH, right? Multiplied by the number of knots, right? That they're creating.
Yes, that's correct.
Yeah. So initially, okay, so they're supplying at least the 8 ETH multiplied by the number of knots to the compound staking strategy. The compound staking strategy, as you quite rightly pointed out, will utilize the ETH in the borrowing pool to borrow the 24 ETH per knot. So it takes the 8 from the user, takes the rest from the borrowing pool, and achieves the threshold of 32, 32, 32, 32. And it will, if the user doesn't have a smart wallet, it will help them create one. But it will manage a smart wallet until the debt's repaid, right? So the user can walk away with the wallet with the slot tokens in it, right? But it's not until the direct debt's paid, right? Basically, the compound staking strategy will take care of that by going to the Stakehouse protocol when the user comes back and says, right, I give me my smart wallet, give me, the validator has reached eligibility, right? So, essentially, what we're looking for here is for any particular proposer, you can see that you reach eligibility way before activation. So the Stakehouse protocol will allow you to mint at this point, for example, with this validator, you'd be minting and repaying your loan 2 days ahead of time, compared to if you had to wait till activation. So, but the compound staking is helping the user here to go to the Stakehouse protocol and say, hey, look, they we're ready to go. Can we have derivatives? So that will get minted into the wallet, like you said, right? So we have this container for management of the repayment. So the money comes in here, right? So Stakehouse protocol will send, okay. So here, so during minting, not during, so they are sent to, once the ETH is, once the ETH is repaid, all right, so I know this is overflowing, but that's essentially what's happening, right?
Yes.
Nice. Guys, you want to discuss maybe the Sartora rules as well for like formal verification of the contracts?
You've got formal verification? Yeah, go for it. Yeah.
Yeah.
Let's do it.
Yeah, right. So basically, I think a formal verification would be best explained if you like put it in a contrast with the unit test. For example, unit tests, when you deploy contracts, you write specific rules like A, B, C, D. If A happens, then, B must be true, etc. And you specify a specific inputs and, watch the specific actions. And formal verification tools are more used to kind of prove more general statements. So for example, instead of after deploying the contract, please make a transfer from address A to address B, you can, instead of that statement, you can prove regardless of who's transferring to whom, the total balance is conserved, for example. So it's more like a tool to mathematically prove general statements, like to put it concisely.
We can do solvency checks, etc., on a very specific scenarios.
Well, you can do solvency checks and etc. on very general scenarios, which means that regardless, even on scenarios that might be like corner cases and might not be even possible to cover inside the unit. So yeah, I think that's why it's so powerful.
Would you do the bytecode analysis too?
Well, yeah, it is based on bytecode analysis, right? So whenever the rules are essentially compared against bytes, so even the compiler bugs could be found by formal verification if needed. So right.
So is it similar in principle to something like maybe fuzzing tests, but sort of extended? Because you said that it tries to sort of break or check those rules in a variety of scenarios, which I assume means that it just iterates through a large sort of parameter space, basically.
Yeah, so I would say that fuzzing is something in between the unit tests and formal verification. Formal verification is essentially even more general than fuzzing. So it's not taking random values. It's not taking some sort of distribution of inputs, but rather it checks the given rule over all of the distribution of possible inputs. So yeah, it is an extension of.
So this is like you write some kind of properties, so like in the property testing that we do, but it's like you have to write a specification for that, each and every scenarios, right? Rules.
Exactly. Yeah.
How do you do this?
So, right. So I'm about to get into it. So,
right, cool.
Essentially, the specification works by compiling the contract code and essentially compares the general scenario to possible sets of contract scenarios with this SMT solver provided by Sartora. I guess you can always dive deeper on how that works because it's out of the scope, at least.
So you're using a tooling for this?
Yeah, the tooling.
Okay.
Right, and the whole testing essentially works in a way that you describe rules and invariants for that you want to check, and rule is essentially just a general rule. So, for example, whenever I'm transferring money from A to B, the balance of address A decreases by the amount, and the balance of address B increases by the amount. So for example, that's a rule. An invariant is that no matter which function I call, the total supply remains constant, with the exception if I call, for example, mint token. So that would be the invariant. So yeah, the two kind of the basis vectors of this testing is rules of an invariant, essentially. So here we're looking at the compound staking borrow pool contract. So here we essentially tested three main contracts: the smart wallet, the compound staking strategy, and compound borrowing pool. I think it's best if we start with the smart wallet, right? Right. So I guess it would definitely it's going to be a very good opportunity for Ivan to also evaluate if the testing was done properly. So yeah, let's get into it. So the first rule that we ran but essentially transfer implies approval. So the rule essentially says that given an owner, a recipient and a sender, this is the three parties are necessary because the wallet has the approve functionality. In this line, like we require that the recipient to not be the address 0, yeah, and that the message.sender, which is just the essentially the address calling the function, is not the sender. And given the like before calling the function to transfer ownership, we essentially check was the transfer approved, and after transfer ownership, so basically if the function doesn't fail of ownership transfer, it means that the recipient was specified as the owner, or and the function was approved. So essentially this sequence of actions.
So how is this different to a unit test, Justin?
Right. So essentially the tool provides, first of all, the general initial conditions. So let's say in unit testing, I would have to I would have to generate an infinite number of addresses in, well, not infinite, but like basically infinite number of addresses. And I would have to manually drive the contract from initial state to the desired state. So for example, I would have to make 50 transactions from address A to address B, and then set the inherited contract in a specific state, and then call the function, and then check the the configuration of the resulting state, which essentially is possible, but it would take, I mean, it would be a whole different adventure on its own, and it would still not kind of guarantee the general properties.
So this is exhaustive.
What
right?
transfer ownership does here is basically, it's not like a transfer ownership function per se, but what it tries to do is that it tries to use this function under all the initial conditions, right? And then it checks like whether it succeeded or not, and how that correlates to the was approved parameter.
Yes, exactly. And it's not only that, but it's also kind of giving the arbitrary environment. So it's, for example, the environment can contain the payment, it can contain an arbitrary message sender, it can contain like basically the whole parameter space. It checks the whole parameter space. Right. I think we can continue unless.
How does it look like? Can you show us this checking? Like,
of course, yes.
Can you run the test or somewhere so it just shows us something? What's the result?
Yes, definitely. Right. So let's say. Okay.
If you done this report, there should be some report, right? If you run.
Yeah. I definitely have the reports, I think, in the comments. So let's see.
Sator has a very nice reporting structure. It shows about whatever you run.
Right. Well, yeah. I think it's best if I include the links inside the compound staking repo or shared elsewhere. Because
Yeah.
yeah. So right. Cool. So I think it's yeah, we can continue with the rules. So the other rule for wallets is essentially given the owner before, like we're taking the owner before we calling the method, right? Then we are calling essentially any arbitrary method in the contract with arbitrary parameters and arbitrary environment. And after the after executing the function, we are essentially checking that if after the function is called, owner before is not equal to current owner, this condition implies that the function called was actually transfer ownership, or the function call was renounce ownership. So this is essentially like a pretty powerful rule, because in like what I would say 10, 11 lines of code, you can essentially prove that it's only possible to transfer ownership by calling the following functions. Right, and a pretty similar type of rule is the following rule. So it's the only one function can set the approval, and meaning that if the approval status changed, essentially, here I think it's worth mentioning that we are filtering a few functions. So we're filtering the initialize, so we're not considering the function initialize, and we're not considering the function transfer ownership, because that is actually a fairly straightforward function, and we're here more looking for like bugs and like unexpected behavior than more than kind of essentially confirming like obvious facts, let's say. So right, so yeah, the function works pretty similar. The approval before, you call an arbitrary function with arbitrary environment and arbitrary parameters, and after that you check the approve mapping. I think approve mapping, Ivan, is the mapping that the sender can approve the recipient, or vice versa, right? Like the just transfer ownership of the wallet on behalf of someone. And right, so if the approval status changed, it implies that the function call was set approval. Does that make sense?
Yes, I suppose, although I think the actual getter is named differently in the contract. So what was that about?
Yeah, so actually a very good question. In order to, like, I would say more efficiently test the contracts, I wrote these kind of dummy mock contracts on top of it. So basically I wrote like mock smart wallet, imported your contracts, and added additional functionality on top of it. So for example, to get the mapping, because I as far as I remember, the mapping wasn't public, and or at least in the tool you couldn't fetch the mapping directly. Hence I had to like define a function, like one of those, yeah. And yeah, so
it's actually not public. You're correct. I don't even think that it has a. Oh no, it has a getter actually. It's transfer approved.
Oh right, okay. Well, you know, I would kind of say like it doesn't hurt by having a mock contract, since I needed additional functionality. So
one general question I wanted to ask is, when we define like this random sort of environment, what does that mean exactly? Does that mean that it basically just takes the state of the contract and just takes a lot of like random states and tries to work with that, or is it like some kind of a different process? Because in general, like modeling a random environment is a very complicated thing, right? So you have to basically just consider a lot of different rules by which your envisioned environment works. But what you could also do is just take, let's say, the Ethereum state, right, and just take bunch of random states. Most of them won't make sense, but some of them will. But that would take like an enormous amount of computation power.
Exactly. Actually, very, very good question. So basically, Sartora tool allows us to separate. Basically, it allows us to separate the Ethereum environment and essentially the contract state. So Ethereum environment, for example, you have this variable E, and the variable E allows you to say, okay, the contract not the contract, but like the entity interacting with the contract has a balance of 5 ETH. The entity interacting with the contract is address 0, is address 1, is address 2, for example. The entity interacting with the contract, it can have the timestamp, like the timing, the block, etc. All the outside the contract environment can be modified through the variable. And the in-contract environment is essentially modified more and use these like require. Obviously, the external can also be modified. And how that's done, it's actually a distinction between like fuzzing and formal verifications. That fuzzing takes random inputs, formal verification takes arbitrary inputs. So basically, the way the Sartora tool works is that they once the bytecode is sent to them together with a spec, their solver essentially forms different constraints and equations and looks for violations for these equations. Like, yeah. So I mean that would be the summary.
Well, what I was wondering about is basically like you could like call, let's say, a function like I don't know, let's say function f, right? Like, right, it's not very, but you could call it from different kind of states of the contract. So in the contract, you have those different like mappings, because like the wallet contract, it's very simple. But if you have, let's say, a contract like an Ava pool or something like that, you would have a lot of different states it can be in and a lot of different mappings and their values. So does Sartora actually like iterate for that as well? Or is it only like external environment parameters, but then you would have to sort of define the internal parameters yourself?
It iterates both through external. Well, iterates is not a very, I would say, precise definition. More like it looks for violations both concerning the external parameters and the internal parameters of the contract. So for example, a very simple example would be you cannot mint the tokens unless the block is above like 10 million, and it essentially
would violate that.
Exactly. It tries to find a state that violates the given specification, and if it can't find the state, then you succeeded at it. But if you can, then you take a look and see what's wrong.
So the internal state is the thing that's being solved for, but the external state is the variable.
I would say not really. I would say that external state is also being solved for, but you specify the constraints on the external state. So for example, you specify that, okay, the block is above a certain height, the timestamp is above a certain height. You can, it actually very depends on the specification that you're writing.
I mean, I don't really want to think about the external state, because it's random as far as I'm concerned, right? When I write like a contract, I do not keep in mind in particular most of the time, like, okay, it will be working within like this scope of blocks, right? Or like with these kinds of things.
Right, but you don't really have to. Like, as in, most of the time you just specify an arbitrary external state. And one thing worth mentioning is that the tool actually solves, like it only considers the paths when the function succeeded by default. So let's say, if you have a require that message that sender must be an owner, the tool will not find violations where the message that sender is not an owner, because all these calls failed.
Like,
Right. So
what if I have a call on an external contract that fails, but I handle it?
in which sense handle?
In the sense that I have a try catch.
Good question. So as long as the contract does not revert itself, like it does not really matter for the purpose of the tool check. We're talking here about the scenarios like unhandled errors, unhandled failed paths.
And like how does it actually handle like external contracts? So if I have a contract that like heavily utilizes Curve, let's say, I do not necessarily want to write rules for Curve as well. So would I be just able to specify like like I want these Curve contracts to be like the contracts that my contract talks to, and so it would just account for that, or is it more complicated?
It is fairly straightforward, actually. You specify the contract, essentially the contract body, the contract code where the function should refer to. So for example, whenever you're calling like an external contract, you define, maybe actually I can show you.
If you have any rules for interactions with Stakehouse, that would probably be more most educational.
Well,
strategy, yes.
I think actually I don't have. I don't recall having exact interactions with the Stakehouse, but there's an interaction with linear model that you wrote. So essentially,
my question was more about the contracts. I do not necessarily know. Like if I'm interacting with Curve, right? Like Curve has a million different interfaces for their pools, right? So I don't want to specify each particular interface. I just wanted to point at a particular address and saying, okay, I have a contract there, and I interact with it.
Right. Yeah. So it sounds to me like you're describing something similar to like forking the mainnet when running unit tests.
In a sense, right? I guess you would have to fork like mainnet to actually check that. So because you do not know in advance how those contracts would work.
That's more of a property testing. You can do it with Foundry.
I mean, I do that with Foundry, but
yeah, that you don't need Certor to do that. That's very easy to do it. The Certor does is like more of like the patch sequence, so the rules and invariants, and then the storage. So there are three categories, and then the specification is written in their own language, CVL. And then it goes through all the center. It has this Certor approver, has this cloud, and when it checks.
What I mean is like, if I interact with Curve, right, the functioning of my contract may be determined by whatever like Curve returns to me, right? So what I was wondering is like the Certor doesn't have to handle like the internal workings of Curve, but what it would have to handle is maybe the outputs or like some kind of a token that it sends to me, right? So verify the function of my contract in particular. So like
so
it returns to me like a value of, let's say, like 10,000. Well, what happens inside my contract?
So I get your question. So basically, the Certora, the formal verification in general is more concerned with like internal correctness rather than global correctness. And if you would write a contract like that, it would essentially assume an arbitrary output from the curve, even though the curve might not, it might not even be possible according to the internal curve's logic.
That's enough. That's actually what I was asking about. So if it just assumes that whatever comes from curve is like a random value and works with that's fine for me.
Yes.
Like not random, just a parameter.
Exactly. So just a parameter, but again, you're free to approximate that output with the constraints you specify. So you could specify that. Define some sort of like approximate formula or whatever, or boundaries that you want for the output. So it's not totally arbitrary, but it's not exactly what it would do in the mainnet. Let's call it this way.
Yeah, I guess so.
Yeah, right. Cool. So I guess we can go into then compound staking borrowing pool. This is like a more interesting contract. So one invariant that I wrote here is essentially that the global time only increases. It's a very simple one, but I think it's an important one. So basically, you take the timestamp, you call an arbitrary function, and if the timestamp was updated, it was updated to the bigger than previous timestamp or equal, essentially. That's yeah, that's just like a temporal property. Yeah, so similar type of methods like I discussed before is just that only the so essentially only the borrow method can set the debtor status to true. So status was false and it was set to true. The selector was the borrow selector. I think yes. Here we can go into more interesting functions like that uses formulas that Ivan described. So so essentially the rule is as follows. So if when I'm depositing liquidity into the borrowing pools, the shares, the expected number of share delta, so current balance of share delta minus the previous balance of share delta, well, not delta, but just the difference.
The share delta is like the difference, yeah. Already.
Yeah, exactly. So is essentially obeys the computations described in the contract, that there's no other way of increasing the number of shares but just using the following functions. So I think I just took it from the contract essentially, that you had the minimum assumed liquid.
That because you limit the functions to deposit only. So do you actually check that you cannot increase the number of shares by any other function? That would be interesting.
Let me see. Actually, I think we'll see later if I did it. Like, to be honest, I don't remember off the top of my head, but that's a good one to do if it doesn't exist. Yeah. Right. So a very, very similar update here is that I think this is a more of a stronger statement, that it's related to the indices that you described earlier today. It's basically that if the index changes, it implies that the new index is actually computed based on the update rules that you described in the contract. So the rules are essentially defined here. Like, in your opinion, does that make sense, like this verification?
I guess yes. Yeah, that's right.
Yeah, cool. So right, it's essentially, I mean, I think it's a very powerful statement actually, because basically if the variable changes, it can only mean that the variable was computed by using the method that was intended to be used. So yeah.
Okay. Did you actually check that the index is non-decreasing? I think that's also pretty important.
Okay, that's a very good suggestion. Let's see if we'll see actually if it's there, but if it's not, I'll definitely include it. So yeah, so also some basic mechanics. So basically, if the interest rate model changed, so essentially if the contract of the interest rate model, because like by default the interest rate is linear, right? It means that it implies that the address of the sender had the configurator role. Right. I mean, and I would say identical reasoning for other global variables. So for example, for minimum deposit and for deprecating the contract, you have to have the configurator role. Hence, it's only possible to do that. But right, and So in a very similar manner, I think that balance before, balance after. Right. The balance, get balance, what does that function describe actually? I think it described, yeah, it described ETH. It described the ETH balance of the borrowing pool. So it means that if the balance after is less than balance before, it only means that the function, that the possible function calls were the borrow function, hence, ETH leaves the contract when you're borrowing, or the withdraw function when you like withdraw liquidity, right?
All right. Yeah.
Right. So, yeah, as in this essentially proves if the rule passes that, which it does, that you can't drain the pool in any other way.
Like, remember the thing that we discussed earlier about like external results? How would you actually like write that in Sartora? Like, if let's say I have like a contract with a particular interface, so how would I actually tell Sartora to search across those results?
Very good question. So essentially, one example that I even see here is in compound staking strategy, you're essentially calling the borrowing pool. Also in the diagram that Vince just drew, right? Like you're calling the borrowing pool, which is an external contract, which means that the Sartora tool does not necessarily know about it unless you define it. So what you can do is essentially define the external contracts function kind of the selector, right? So we have the borrow, which it takes the address UNT56 and another address, and you map it into the kind of into the mode in which in which it should be treated. So here, for example, since I actually have the contract at my disposal, right? I specify the contract location in the specification and I map it to dispatcher true. In the case you described, for example, the curve, where you would not necessarily have the interface. Well, you would have the interface, but you would not necessarily have the code that would execute it. You would map it into some other mode of treatment. So, for example, return an arbitrary variable or some sort of other treatment. But the syntax would look as follows.
Okay, I see.
Mm-hmm. Right. So inside the compound staking strategy, very similar temporal properties. So, for example, position timestamp. I think position is essentially just like the debt position, right? It means that the position timestamp before is not equal to position timestamp afterwards, which implies that the position timestamp afterwards is more than or equal to position timestamp before, right? Because like the position of the debt position can only move forwards in time, essentially.
Okay.
Right. I think these are the invariants that if I recall correctly, you personally recommended. So it means that if you take the initiator of the position is 0, so 0 is the 0 address, if and only if the position status is less than or equal to 1, which is uninitialized, if I recall correctly. There's just like timestamp. The status is converted into uint8 here.
That's I also use that a lot. Yeah.
Right. So I essentially in this line I require it to be true. I'm saying the tool, give me the contract state where this is the case for all the addresses, and I call an arbitrary function then, like f, with arbitrary arguments and arbitrary environment. And I'm saying, okay, I assert it, I require it to still be true, right? Because if, for example, the position status is like 3, but its initiator is still 0, means that we have a bug.
Like when you define like the function f, does that mean that it will always just call a single function between those like checks, or can it call like a series of functions, for example?
It is like it's only gonna call a single function on the contract interface by default, right? So at least in these specs. So yeah.
Can I somehow make it like call a sequence of functions?
You can by defining a mock contract and just giving different combinations, but it's more of a manual process.
Okay, I see.
Yeah. Right. So it's very similar in variant to the previous one. I think also suggested by you is that if taken the number of knots is 0, if and only if the position is less than or equal to, I think, registered, right? Same thing. You require it to be true. You call an arbitrary function with arbitrary parameters, and you assert that it's true after, like it doesn't change essentially after any possible call. Right. So this is another rule oriented around status. So this is actually a pretty interesting one. So given the position status before, the position status after can only be more than or equal position status before, or if you reset the position, correct me if I'm wrong, Ivan, but if you like pay back to that, right? Or if your like position gets
it resets to initialized, yes.
Exactly. So the status of the wallet can only be changed in the following order. Right. So essentially, this is a structurally identical rule, I would say. Just I defined a function exactly to how Solidity updates the status as far as I remember, and just saying that okay, if the status before is not equal status after, I want to see how it changed based on the status before. And yeah, and the final rule, I think it's very important to like secure the properties mathematically, essentially prove the security of the funds between contracts is funding conserves ETH balance. So I'm taking the contract balance of the compound staking strategy contract, and I'm taking the ETH balance of the borrowing pool, and I take the sum of them, right? And I essentially fund the knots, and after funding the knots, the sum should essentially be equal. But here, obviously, we have a kind of a caveat, since the ETH is sent to the deposit contract, we also have to account for that, right? But kind of that's essentially this property makes sure that the ETH does not go where it shouldn't go. Like it's either in the borrowing pool, in the strategy, or well, it's never actually in the strategy, but like just in case, can I counter for it, or in the deposit contract.
Okay. Could you scroll a bit up? I have a question about the one with the initiator and the position status.
Which exactly?
This one on the top, yeah.
Uh-huh.
So does this handle also a situation where you would call, let's say, repay, and then it would reset the initiator to 0?
Yes, it would, since the contract is in the arbitrary state, and essentially it checks the arbitrary state transition. So in your example, you would have a wallet with let's say, I don't know, status, I think 3 or 4, whatever it was before repaying the loan. let's say the F is equal to repay, you would repay, and your position would be set back to 1. So yes, it would handle that case.
Okay, I see. So that's why you actually need to like write it twice before and after the function.
Well, I write it twice. So I first write it with require. So essentially, I enforce my will on the state. I'm saying to Sartora tool, I want the state to obey the following kind of relationship. Then I'm calling that function. I'm calling an arbitrary state transition, and I'm essentially asserting. I'm saying, okay, check if that is still true. So it's more like I'm bringing the contract to a specific state, and after that, I'm making sure that it stays like the invariant still holds.
I see. So the require statement still does allow for cases where the initiator is not 0, but the position status is actually like different, higher than 1. So as long as this invariant like does not hold.
Right. So the require statement allows for for example, kind of situations where the position status is, for example, above 1, and but then initiator wallet is not 0. So essentially, it just enforces the relationship in between those two variables.
You need to do that to avoid situations where it would define like a random state where this is not true.
Yes, exactly. So for example, as I said, the Sartora tool starts with an arbitrary state. Hence, yes, correct. It could start, for example, that the status is that the initiator is 0, but the status is like 2, and then it would automatically fail our check. Right. So I think at this point we covered most of the rules. Yeah.
Thanks. That was useful. I'm actually like looking at Sartora to use in my own work as well in the future and trying to learn more about it.
Yeah. Well, cool.
How does the Sartora show you if there's something has been violated in there? Like if you look at the report, like
very good question. So basically, this is an example of a Sartora report. So I'm looking at the ownable smart wallet contract written by Ivan. So basically, in this case, we do not have any violations, but we can check, for example. So we don't have any info since it's all passes. But in the case it would fail,
can you
make
it fail?
Definitely.
How does it work? Like, all right.
1 second. So right. So for example,
Sartora is a very, very effective tool in terms of like, do a lot of checking that is not possible with fuzzing or property testing or anything.
Right. So for example, let's say the same smart wallet, because it runs fast. So something like okay. Forgot the semicolon. Right, so it should take this since in general rules for Sartora varies quite a lot based on complexity. So this smart wallet contract actually takes, we'll see, like it usually takes under like a few minutes. But if you have some complex math or hashing or signature verification, it can take up to 2 hours. So yeah, just as a fun fact.
If I have like a 2,000 line contract, like how long would that take?
Well, the problem is, the problem is not in the number of lines, but it's more like if you do complex operations. So one example, for example, is quite heavy is hashing. Like if you compare hashes, because they internally, as far as I understand, build some sort of like tree of possible outcomes, and then like derive state based off of that. So yeah, that can take quite a while.
That sounds actually very similar to like ZK provers as well, doesn't it?
Mm-hmm.
Like they have to map the entire tree at once.
Yeah, I'm pretty sure they do definitely share quite a big intersection. So this is an example of the tool failing. So for example, but because I manually made it fail, and we can see an example of a violation. So for example, owner before variable was set to 0x271. The recipient was true. This condition was satisfied that the recipient was not zero. The message that sender was sender. Right. So we have that the function was approved was set to true. And transfer ownership, we can see like the essentially called data logs over here. Right, and at the end of the day, it shows me that this condition failed, which it should obviously assert false.
Right? Could you show me how would I write, like, if I want to make an invariant that is that holds for any address? So let's say I have a mapping, right, and it's a mapping from address to address, and I want to check that if like the value of a mapping from my address is not equal to like 0 address, then some condition holds for address for my address. So like mapping from A not equal to 0 address means that condition of A equal true.
Yeah, definitely.
I'll write something like that.
Yeah. So as in, since you described it to me in a very abstract manner, I can like show you in an abstract manner. So essentially, right, you would describe your invariant, you would have your environment, you would have your function, let's say in this function, and let's say you would have some sort of function that get value from mapping, right?
Okay.
You would define, you said address A, right? Address B, right? And let's say we have like 0 address.
Address B is not necessary because I just want to check this for one address. So basically there's like mapping value from address, and then there is the condition where you also pass an address.
Yeah, definitely. So for example, get value from my mapping.
What I mean is just how would I define like a random address? And I guess what you mean here is that you just write address A and that's it.
Yeah, exactly. Okay. You would exactly, you just define the variable and it takes a random values. No, not random, arbitrary. Cool.
Okay, cool.
All right, that's pretty cool actually. So we have all this, the tooling, it's available. It's downloadable in the GitHub, right? So is there anything else that we want to understand this, like the compound staking? But let me ask this question that I have with this in mind when we talked about this borrowing strategy, right? effectively an LSD network contract can deploy this borrowing strategy as a separate pool. Correct, guys? I mean, what's the difference? In an LSD network, you have giant pool, like, outsourcing the liquidity needed. So here it is, like you just asked people to send the strategy pool, and then you put up 8 ETH or 4 ETH, whatever it is. You can even source 4 ETH from the giant pool, and rest of the 24 ETH is from the borrowing pool. Would that possible?
Should be. And what more I can think here is, since other stakers have the minimum staking out of 0.001 ethers, so I mean they can scale it as much as they want, but more benefit can be taken from the node operators because they directly need 4 ethers. So it will be pretty cool if we lower down the ETH restriction in the compound staking strategy, so that the node operators can fund even more nodes, and that will mean that any amount of stakers, and say thousands of stakers, can come in, and they'll be able to use already provided BLS public keys. So that is a very good idea.
All right, nice. Can't see like how many plumbing can be made to LSD. So compound staking pool could be essentially supplying this kind of capital required for liquid staking networks from protocol directly. And this is like a very familiar strategy. Like you get, the capital providers get this kind of interest rate for some days, and then it just goes to the DE that can be sold into a pool, Uniswap, or somewhere where they just want to source more DE. People who are providing initial capital is different. The protocol who want to get supply to the DE is different. It could be a roll-up or something. So there are many ways that you can slice this in the ecosystem, right?
Yeah. I think the two primitives, the compound staking and liquid staking derivative networks, can be sliced up quite nicely to build things not only on top of LSD or compound staking, but things that work alongside. It's just a case of providing like home for the ETH liquidity that's being provided. There's lots of ETH out there, but not a lot of understanding of how to use that capital effectively. You're talking about DAOs that have huge ETH treasuries. There's many to list, and providing them the most capital efficient way of getting exposure to stake the ETH as possible, depending on their risk profiles, really. But we've got the ability to build any instrument we want.
Nice. All right, so next frontier market is staked ETH yield, I believe.
Direct from consensus chain.
Yeah, I mean, in the compound staking, it's not only for that. The interest rate is currently only for 24 ETH, but it could also, Ivan, is it possible to rehypothecate like your earnings of that 8 ETH and to borrow against it, like some kind of strategy on top of this? Like you can borrow even that from outside.
I suppose, but you would have to find some way to like pass ownership of the wallet between two contracts. So like the strategy only collateralizes the debt that you get from the pool. But if you find a way to actually share the ownership of that wallet between two contracts, you can, for example, collateralize the debt with the ETH that you mint from the strategy, and then collateralize some other thing with slot. Yeah, I guess so. Because the slot right now is like it's or like future minted slot, it's not used as collateral, right? So I guess you can use that. It's not even really sorry, I cannot pronounce the word ever, but it's not like you use as collateral, so it's not even that. It's basically you just take unused liquidity and collateralize it.
Great, thanks, guys. I'm just gonna, I'm just gonna dig in deep into this compound staking. Very interesting. Cool.
Thanks, guys.
Thank you.
Thanks, Bye.
Thank you guys. Bye.